Hello, pre-calculus students, and welcome to the introduction on exponential and logistic functions. In this video, we're going to deal primarily with exponential functions. We will deal with logistic functions at a later time. So let's look at some of these definitions and see if we can apply them correctly. Okay? So an exponential function is a function that can be written as f of x equals a times b to the x. A here is any real number that's non-zero, and it's called the initial value. B is any real number, it's called the base, but it has to be positive and not equal to 1. So let's look at these examples. X to the 7th. This is not an exponential function because the variable here, this is a variable, so the exponent is a variable, whereas in this example it is not. So the exponent, not a variable. Here, 3 to the x, that's absolutely an exponential function. The initial value is 1, and the base is 3. Same thing here, also true. The initial value is also 1, and the base is pi. Okay? B can be any real number. That includes pi. Here you have a negative number in front, so that's not so. Let's see. That's fine. Okay, nothing wrong with that. But again, the exponent is not a variable. Next one, 17 times 2 to the negative x. Well, does this negative make any difference? Well, let's see. This is really 17 times 2 to the negative 1 to the x, which is really 17 times 1/2 to the x. Okay. So this is an exponential function. The initial value is 17, and the base here is actually 1/2. Okay, so it's a little bit deceptive, but you have to pick that out. Number 6, this is also an exponential. A can be anything as long as it's not 0, so that includes negative. So the initial value is negative 2. The base is 5 to the 3rd, which is 125. This particular function, 2 times negative 5 to the x, this is a problem here because the base here should be positive, and that's not true. Okay. And finally, the last one, also not a function because the base is a variable. The exponent has to be a variable. The base cannot be a variable. It has to be an actual number. So there you have it. You can see from here just some basic concepts here on what an exponential function really is. We're going to continue now and just look at a graph. And you can use almost any base here. I picked 2 just because it's a familiar number. And our number is 2, 2, so we're increasing by 2 here. So what's f of 0? Well, f of 0 is 2 to the 0, so that's just 1. F of 1 is 2 to the 1st, so that's just 2. And then f of 2 is 2 squared, so that's 4. Okay. And you can see that it's going to make this shape. You can also use your graphing calculator to help you. The domain here is all real numbers. You can put any number you want into for that exponent. The range is just the positive numbers, and I'll show you why. What if you did 2 to the x equals 0? It looks like it touches 0, but this is ever true? Well, this equation right here has no solution. There is no number that you put in for x that will possibly give you 0. There's no symmetry here. It's always continuous from negative infinity to positive infinity. It is always increasing from negative infinity to positive infinity. We know that it's never going to touch 0, so it has an asymptote here. And this is an asymptote as x approaches negative infinity. The function is going to approach 0. There are no vertical asymptotes because as you go towards the right, this line here just explodes and goes straight up forever. It's not going to approach any particular finite value. And the end behavior, we already got one part right here. I'll just rewrite it. Limit of f of x as x approaches negative infinity is 0. And the limit of f of x as x approaches infinity is infinity. This is just going to shoot up forever. Okay. And so there you have it. Just a quick analysis of this function. If you graph it, it'll help a lot. We also have to think about, whether certain numbers are possible in there at all. Thank you for watching. Have a wonderful day. Be sure to watch the next video when we talk about how to write exponential functions.